any norm. Yeah, this is like common sense. This is all that this principle is the underlying principle of everything that you study in this course as well as in your optimization course. Right? This principle is the underlying principle of everything that you will study in this course as well as your optimization course. Yeah. Now, what I'm saying here is that you move in any direction, your value should increase or decrease. Now, to be able to check this, what do you need? You need to have an idea of direction. What do you mean when you say I move in a certain direction? What do you mean when you say you move in a certain direction? If I look at a three-dimensional space, you have an idea of what directions to move in. You can move up, down, everywhere. So now, when you look at a three-dimensional space, if I'm looking at a function defined on a three-dimensional space, so how can you look at that? You can look at, say, temperature at every point in this room. You can look at temperature at every point in this room. So if I say that there is a point in this room which has minimum temperature, what will you do? You can move in any direction from that point and see whether the temperature increases. That will at least define a minima. It need not be a global minima, but at least it will be a local minima. So if I move in any direction, now you have an idea of what you mean by moving in any direction in a three-dimensional space. Right? On a two-dimensional space, you know what you mean by moving in any direction. Now, when you're looking at these trajectories, what do you mean by moving in any direction? What are the possible directions that you have in this trajectory? Along the path of the trajectory. Okay, what do you mean by that? Now, when I'm looking at this, so if I have a trajectory like this, now what are all the directions that I can take? What are all the deviations that I can take from this?
Derivative at that point, like for this.
Derivative. Why? Think of this now. You need to move along. You don't need derivative for direction. No? Direction is a more basic principle than derivative. Now this is your vector space. So when you're saying you're moving in a certain direction, you're like moving along very small vectors in a certain direction, right? So now what are all the possible directions here?
So we take a delta ball and that should be within the vector space.
You take a delta ball in the sense?
So beta ball is the ball of the, like, if delta is a very small quantity. Suppose we have a point x naught and we want to move in a certain direction.
So here your point is a trajectory.
No sir, the point is x naught on the trajectory and we want to move from that point to some other point.
So here when you are looking at the space of trajectories, what are points? So firstly, when you want to define a space, when you want to define a vector space, you need to see what is a point in that vector space. So when you have this room as a three-dimensional vector space, you know a point is a point here.